Everyone, my name is Jordan Hernandez. Today I'll be demonstrating my demo 0 for the circuit to show that 8 minus 3 could equal to 5 through this. So first off, what we wanted to do is have two of those values, which is 8 and 3. So ROM 0 is just going to be representing our first number, which is going to be 8, which is 1000. On our next one, we're going to have ROM 1 represent 3, which is going to be 0011. All right. So now once we inputted those two numbers, we click this read machine, which basically this read button that basically makes the whole circuitry read the numbers, which it does later on, as we can see that it's reading 8. But we don't want it to read 8, and the reason why it's reading 8 right now is because we have this address being 000, which indicates that it will want to go for this first value. But we wanted to have 3 in store B. So what we do is that we press the first one being right here, to which we can have 3 go up here, and A or B, so that will be a little bit later. So then now we wanted number 3 to be stored in this memory so that we can then transfer to B, to having two different numbers in the system. So first we're going to click E and B, and then we're going to click the clock button to then store B could read that number. All right. So now we're going to turn off this machine and the clock machine. And then now we're going to turn this one off, and then we're going to have 8 kind of go up through the circuit now. And now since we don't want A to go through here, we're going to turn on the A or B machine, which then switches our wires to go up here to A. Here we have the selection mode button, to which we have subtract A minus B being 0, add A plus B being 1, multiply L as 4 being 2, and then multiply M as 4, which is 3. For right now, we're only doing subtract A minus B, which is what we can have is both 8 being right here and 3 being B. To which you can see when we have it right here that A equals 0101, which is 5. And the way we can tell is by clicking this button right here, which is our accumulator button, and then pressing clock, which then equals our answer, which is 5. Now what we wanted to do is that we wanted the 5 to show up in one of these RAMs down here, which is RAM 6, according to the instructions. So when we clicked the account out, it shows up an error, and the reason why this shows up as an error is because we have read on. We can't have too many sources being on at once, so all we gotta do is just turn this off, and now we have 5 basically going throughout most through the wire. Then we shall go over here, to which it's going through the RAM. And since we wanted to go through RAM 6, we now would like to go up here. I'm going to turn off this clock real quick. So then now we wanted to make the wire to go through 6, which is the address button up here, and I believe it's going to be 110. Yes, as you can see, the green wire is now turning on these two components right over here. To then we can now click the write button, which then is another button that can help us write out the answer into these boxes. And then all we got to do is just click the clock button, and now we have answer number 5 being in RAM 6. All right. Now to our questions. Our first question is going to be, is this machine digital or analog? And this machine is going to be digital. And the reason why it's going to be digital is due to our 0010 binary codes represented here. If this was analog, it would be more of a continuous value. Our second question is, what is a bit and how many bits are in each of these microprocessors registers? So, bits are binary code in the system, and how we can tell that how the bits are made. So all we gotta do is just click one of these registers, and it shows up as our data bits, which is how many code is inside of there, which is 4. And which is true throughout this whole system, as we have 4 values that we can enter in. Our third question is, what is a register and why are registers important for computers? So, registers are just groups of binary code inside the machine, and the reason why they are important is that they can store different types of codes inside the machine. The fourth one is, where are the registers in the microprocessor, and what type of processors are these? So the first one that we actually go through is our store B right here. And this one is going to be a serial in/out. And the reason why is because we have this value going through in here and it comes out through the other end. And for the accumulator is also the same function as well. It's going to be a serial in and/out. And again, when you enter this value, it goes out through here. On to the next one, we have these three down here, which are also registers for RAM 5, RAM 6, RAM 7, and these ones are going to be parallel in/out. And the reason due is because all these are in parallel in the same circuits. Hope you guys all enjoy. I'll see you all tomorrow.